I think Radek is planning on showing up, and I don't know about Sage, but hopefully we'll get him too. And Greg, I believe this is another lesson that I need to send out reminders about this meeting because last week when I did, we got far more people. Right, well, maybe this is it. Let's just get going. So let's see. There was a couple. Well, there's actually a number of closed pull requests here. Nothing new though. Sage removed some dead code for a mutex perf counter. We didn't use it anywhere apparently, but it's just slowing everything down. So that's good. There's this avoid heap allocations for most log entries. This is MDS, if I remember right, which is fantastic. Good. Oh, good. Sage, you're here. You can go over the merged PRs. Probably do a better job of it than me. I think you're muted, Sage, if you're trying to talk. I'm not sure.
There we go. Okay. All right. All right. So this first one. This is first pull request. Killing the mutex perf counters is something that Sam added like 5 years ago, and he used to debug some random thing. I doubt anybody's ever used it since. So pull that out. There's some overhead there, especially with every mutex that used it. The slog heap allocations thing from Patrick went around in circles about 20 times, but looks like that finally merged. Yay. Speeds up the debug log some. This OSD shard thread on commits also had many iterations to get it right, but it is stable and in some cases shows a big improvement. I think it was like as much as 100% for high IOPS and lots of shards. Less impressive for other shard counts. So I think there's probably some figuring out to do around what the right number of shards is given this change. But basically it means that the completions, instead of being queued on a finisher thread, fall back into PG, they just get pushed directly onto the, or processed directly by the regular op work to use thread. So fewer threads, simpler.
Sorry, Sage, is this 22739 you're talking about?
Yeah, yep, that just merged this morning.
Okay. Yeah. Oh, okay.
So it's kind of exciting.
Yeah.
Yeah, if I read his results right, I think he saw double in certain circumstances. Like
interesting.
Is whatchamacallit SSDs. So that's cool. All right, bringing containers with slab allocation. That was close, not merged. I think that was just the old iteration of that when you're working on a newer one. Same thing with this other, and this is an old optimization. Close that up. Let's see, crypto stuff from Peter. What is the status there? No idea.
Waiting for results from in-OSD testing. At the moment, we have only benchmarks.
Okay.
Results from micro benchmarking, which on my machine is still a bit inconclusive, I would say.
Okay. All right. Let's see. Working on the newer version of the containers with embedded allocator inline allocation stuff. And then there's this persistent read-only RBD cache. This is, if I remember correctly, this is using persistent memory as a persistent cache for RBD. So pretty cool, but high-end hardware, but pretty cool. I think the idea is that hopefully some of this infrastructure will be reused to also have for SSD-based or NVMe-based persistent cache on the client side. But the initial implementation is just for persistent memory. But it's pretty cool. Let's see, cache rebetting stuff. Mark's still chasing down that issue. He's blocked on me, I think, so I'm working on that. There's Radix thing with perf counters. Let's see. Dun, dun, dun. There's still Igor's thing, landing tiny appends in the database only. We need to sort that out. I wonder if that would have effect on the hard disk loads.
All right, which one was that, Sage?
23208.
08. Oh, land tiny appends BB only. Maybe it might.
Maybe that might be worth just giving a shot. What happens?
It won't matter with the initial create workload though, right?
Append in this case is at the level of the blob, and so I'm not sure exactly how that maps to the client workload. I think the client workload doesn't necessarily have to be end.
Okay.
Sure. I think it's just small writes basically.
It is interesting in BlueStore that I've noticed over the years that the initial create performance is definitely lower than the overwrite case, and like with an RBD workload. And it's been slower than, that's one of the cases where BlueStore has historically been kind of slower than FileStore. I don't know if it's the initial creation of metadata that's kind of hurting us there or what, but that is one case that seemingly we don't do quite as well as we did with FileStore.
Yep. Okay. Yeah, I think that's it. There's the new stuff.
I wanted to ask you on that RBD persistent cache case, Sage.
Mm-hmm.
Does that, so we talk about replication, right? And as soon as you have your cache fail on the client, I mean, is this something people really?
Yes. So this is
Yeah,
is the thing we've been talking about for a while, where it does ordered write back, and so it's sort of a hybrid mode where it does write back on the client, and so in general, you still have your cache, everything's great. If you lose your client cache or you don't wait for it to come back or you fence it or whatever, because it was doing write back to Rados in an ordered way, then you still have a crash consistent image in Rados, but you just lost some of your recent writes.
Okay.
And so for lots of workloads, this is like fine. If you're like VM, warps back in time 10 seconds is like something that you were shelled into and doing whatever, like it's totally doesn't matter. For other things, it's not okay, right? If it's like a database or something and you need that consistency, then clearly that's not the right model. But the idea is that the hope is that this actually covers a lot of use cases.
You could make the same argument for replication in general, though, right? Like if you write to a primary and you can be, consistent in terms of what actually gets replicated and what doesn't, you could kind of make the same argument for something like that, right?
Yeah. It's just that Rados, all the things built on top of Rados assume stronger consistency, and so we can't do that in Rados. But we could make a different pool that does do something like that, I suppose.
I think it's really different from the consistency model of replication, though, to be fair. In this case, the application's transaction is just different, it has a different granularity than we're expressing.
Yeah. Yep. Okay. What's on the agenda?
I was going to ask Radic to talk about some of his stuff recently because he's been going crazy working on all of this. So Radic, all of your buffer list and mempool work, I find it very interesting. Maybe I'm crazy, but.
Well, I'm working on a couple of things at the moment. The first one is finishing the pull request with slapped allocators. I guess we really need to simplify its design. I'm working on that at the moment. Another thing is buffer list. I'm trying to get rid of the append buffer, and I'm driven by the observation that I think most of the users of buffer list want to still use the C-string taking variant of append. And
Yes.
unfortunately, they are appending small chunks of data, 4 bytes, 8 bytes, something like that. And for such writes, we have really, really significant overhead related to housekeeping of our append buffer of buffer list. We are trying. The current logic is that when somebody puts you a C string, then you are appending it to a append buffer that is private to a buffer list. It's not yet. It might be not linked on the buffers list inside, but you are appending there, and after that, you are trying to slice the space you append it into, and put that using the buffer pointer mechanism on the list.
Yes.
To avoid really huge number of entries on the list, we got a mechanism for merging those buffer pointers, and it's pretty. In my testing, in my micro benchmarking, it's unfortunately pretty costly. So I'm thinking. Yep. Please continue.
Oh, I was going to ask, can we do the same thing we do in Blue Store, where we pre-compute the sizes rather than doing all these little appends?
That's the problem. I don't think so.
Okay.
I can see that the C-string taking variant is used by the old encoding stuff. I'm afraid that I'm not sure. I don't know whether it's possible. I don't think so, but I can be wrong. Anyway, I decided to give a try to another idea. Try to move the overhead from the C-string variant, which seems most important to me, to the buffer pointer taking variant. So instead of merging buffer pointers, we can go with first appending just directly to the very last buffer we have that is linked on the buffer list.
Mm-hmm.
That makes a problem in case where you have mixed workloads. When somebody calls the C-string variant many times, and it's interleaved with the buffer pointer taking variant. In that way, the very next call to C-string variant after appending buffer pointer will result in extra allocation and waste of space, of course. So I guess we could try to get rid of that by splitting the free space, if it's available, if it's there, of course, by the buffer pointer taking variant. That I think it's much rarely used than the C-string. That's I'm working on in the matter of append buffer killing. Another thing is also related to simplifying the buffer list itself. The pull requests for killing unused zero copy facilities are merged right now, and I started working to getting rid of the backward iteration over buffer list. Well, it seems it's not so often used, but it's used in very critical places, like the encode start macro. And as a result, we are paying a pretty significant price just for filling the very metadata, the very beginning metadata of our serialized data structures. Basically, we are just appending some chunks, paying full price for the C-string taking variant. Then we are taking iterator to buffer list and rolling it back by the number of bytes we appended.
What's calling the appends? Like what parts are the hot parts in the code that are
The
doing
old
this?
encoding infrastructure mostly.
And then is that just spread out everywhere?
I am afraid it is.
Okay. Taking notes here and writing into the Etherpad.
I'm also thinking about reducing the memory indirection we have at the moment. We have buffer list that has a pointer to linked structure of buffer pointers. Then each buffer pointer points to buffer row, which
yes.
and some of, not all, because we have combined row, if I recall correctly, but many of them, like page aligned rows, they are still have yet another indirection to their actual data.
Yeah.
I'm thinking I would love to be able to allocate all that place in one malloc. Place for hooks for the container, place for buffer pointer, place for buffer pointer row, and finally the space. Everything in one alloc. It can be complicated because of the necessity to synchronize the lifetimes, but still might be possible.
Sorry, when you said do it all at once with one malloc, do you mean so we've got lots of little appends, right?
Yes. The idea is if you need to allocate a new space,
yes, okay,
to not allocate separately buffer pointer, separately allocate buffer pointer and buffer row, and maybe if the append is big, you don't want to also allocate the data that the buffer row points to.
So would you use placement new then?
Yes.
Basically, malloc.
The same. I would love to extend this the same hack. Very good solution actually. Combined row. I would love to have combined pointers, buffer pointers, Ceph buffer pointers, containing everything we would need.
Yep.
But it will become the changes. Well, too early to say. At the moment, just an idea.
So that maybe is a good segue into what I want to do, which is instead of something like placement new, right? You use object pools and you just grab whatever's available and have these things pre-allocated already and go that route. I think it would be really interesting to explore. The things I worry about is whether or not how much variability we have in the number of actual objects of these different types in practice. If you've got a certain number of maximum number of IOs that you have outstanding, do you have a reasonable upper bound on the limits, on the number of objects? Maybe occasionally going over, in which case you need to make new ones. and then shrink that back down, or is it really just all over the place? And I have no idea.
That's
Reddick,
the
do you
first
know?
question. Me too. I don't know, really. But there is another
Okay.
question. What is the deviation in size between instances of such objects?
Well,
If
right
they
now,
are pretty similar, if the deviation, if the deviation from average object size is pretty small, then we could we would squeeze unnecessary allocations, initializations, and don't waste much of memory.
so my assumption right now, which could be totally wrong, is that we use pointers and have so much we have so much abstraction that the container objects are probably almost all the same size, right? Because they're just pointing to other pointers of stuff. Um, you have like a buffer pointer, right? And what is it? It's just a collection of pointers to other junk, right? So my assumption is that the pointers are really probably almost all the same size anyway, because they don't really do anything. They're just sitting there, collecting other things. Is that? I mean, Radek, do you think that's true, or am I wrong?
Well, I don't know the answer. Sorry, I can
Yeah,
only
I guess.
speculate.
Yeah, this is my assumption, just having looked at it, that it seems like these containers really don't matter. And probably the right answer is that we should refactor all of this and make it all go away. But assuming that we don't refactor it and make it all go away, I wonder if an object pool would allow us to kind of at least get rid of the creation and destruction of these things, and just kind of set the internals to be different, which I would hope, I guess, would be fairly low overhead relative to the actual creation and destruction of the objects. But I don't know. Maybe TC Malik really already does a good job of that, of kind of optimizing it. I don't know. It's really the
Well,
variable length characters that suck, right?
yeah,
That's underlying the whole
that will
thing.
be having a pool for objects can be reasonable under some constraints. You would need to find a category of objects, a class of objects that is costly in creation, which also includes memory allocation.
It it's so creation is one aspect of it, right? I mean, maybe
Yes.
the creation doesn't necessarily matter that much. But I also wonder about the fragmentation in memory of these things. You
Okay.
know, like buffer pointer. These things are probably scattered all over memory, unless TC Malik does a good job of actually, like, kind of laying them out as a group of things, which I don't know how good it can do at it, or if, with all of the nasty memory patterns we have, if it can't really do a good job of allocating that in a specific area in memory. That's one
I
of the things that's hard about this. Is I don't know.
saw that TC mallocs can actually be costly, but in very limited scenarios. But the problem comes in a situation when you have when your memory flows between threads. If you are making allocation in, let's say, Messenger, then the corresponding deallocation is made by TPOSD-TP. And in profiling during 4K run treats, I can basically see two such places. One is our weighted priority queue. By default, there is four different threads wanting to operate on that. 3 messengers, 1 TPOSD-TP per weighted priority queue instance.
And what are the objects that it's doing operations on? That creates
Sorry?
infrastructure? Which objects?
And OpQ items.
OpQ items.
That's the OpQ items are stored by this queue. Messenger or messenger create enqueues operation, then TP OSD TP pops it out, and this requires some housekeeping work in the weighted priority queue, and because it has a number of layers, 3 or 4, with allocation on each one. Well, it's pretty scattered over memory, and required a lot of allocations. I pacified it with the slapped allocator and can see that, first of all, there is absolutely no malloc overhead. So I guess there is also no cases where no blocking. There is no very rare case of blocking in tcmalloc, I hope, because there is simply no tcmalloc column after that. And the number of cycles spent by a single messenger thread during enqueue operation is lower by I'm guessing around 25%.
So with the slab allocator, when you were working on it, it sounds to me like you're saying that you were able to avoid a lot of those problems.
Because of embedding, mostly because of embedding, of predicting how the structure looks like in typical case, and optimizing for that by embedding, by preparing some pre-allocated space that is part of the queue itself, of the queue object itself.
And when you pre-allocate that memory, are you able to do a good job of predicting about how much will be in memory at any given time, or is it variable? Like, is it good enough just
on
to
some layers? On some layers, in case of weighted priority queue, well, it's complicated, but I got a feeling that it can vary significantly only at the very top of layer of the queue. Top.
Okay.
Sorry, bottom.
Yeah.
Because you have priorities, you have because you have classes that corresponds to addresses of clients. You have priorities. You have a lot of such things.
Yeah.
Anyway, even if you mispredicted, still the load imposed on the memory allocator will be much lower because of allocating in bigger chunks. So even if you deplete the embedded pool, of course, you will go to the allocator, but you will go by 23 times lower, less frequently than than without the slab allocator. And inside of slab, the memory is continuous. Of course, it turns into question whether the physical arrangement of your memory corresponds to logical arrangement of your container. If that's not the case, you still will have plenty of jumping over memory. But
sure.
Hopefully,
Sure. I ask the TC-malloc interaction is the part that I'm trying to get more out of too, because we have this ongoing issue in RGW. But we're not going to be able to avoid, even with in fact, we may even exacerbate, or at least will change and permute, the amount of behavior where we well, we're saying with the SIO work, where we end up deallocating in a different thread. It seems like I'm not sure if this is guaranteed to be. It seems like this is a guaranteed problematic case for TCMalloc, and furthermore, we see it as having a large impact, even in terms of the large amount of memory that's flowing through buffer lists. So it's not just for us. It's what the problem we see is not just about small allocations. It's actually happening even with larger chunks that are being allocated and freed this way. I'm not
Would,
sure why,
would something like
if I recall correctly, bigger there is some threshold. So after crossing, when you crossed, all allocations go outside of the per thread pools in TC. But
so possibly be a different tuning with TCMalloc than other daemons. Alternatively, your description made me wonder if we would benefit from some sort of an allocator flowing through these calls and make it do something like Sambas Talic or equivalent to release all the memory for a request one shot later on.
I don't know the answer, Matthew, but one thing I was wondering is, could you benefit from like an object pool model? Do you have a lot of temporary object?
I'm not clear that's the case. We sort of have a bunch of objects that get created along a request path and then get cleaned up.
So, I mean, is it bound? Is it,
well, it's bounded. It's bounded, but I think the large data stream, the cost of allocating large data streams dominates over, for example, the objects, which are sort of smaller in number for requests and mostly living in our metadata cache, at least as far as I know. We have other things. We have and what I think we have coroutine stacks and a few other things too.
So the data stream itself is the thing that you're more worried about, like allocating and then deallocating in another thread.
Well, I think so because that's from what we can tell. I mean, I went into it. Also, that's the only way we would the TCMalloc allocator could be forcing us into essentially situations. Wouldn't be enough otherwise.
The thing that, like with buffer lists, that I kind of worry or wonder about a little bit is that there are so many like stupid little useless objects that we create in the process that I wonder if that's adding to the problem beyond just the data that we're actually sending around, right? Whereas maybe that's not the case in your situation.
Well, I'm not sure, but I don't think so. But I mean, but we see a lot of to be fair, we've seen not a memory condition. We've also seen, I guess the most persistent thing we've seen is high CPU overhead just churning through the central free list returns. And so I guess that could be either one. Maybe that actually sounds like small allocations. Default thread cache and higher. I think higher seemed to no default as tuned by us. So like 128 meg.
Okay.
I think we doubled it and didn't get much help.
That's really interesting.
No, this has mainly been seen on Xenial. So we've been Xenial. So we've been thinking that possibly there is an interaction with TCMalloc version, but I'm not really sure, and the evidence for looking at code doesn't really strongly support that.
What TCMalloc version is this? Do you know, or what operating system?
Well, what is Xenial? So I forget, it's a 2.6 or something.
Oh.
2.6x.
I'm back in TC.
Yeah, there is a bug in older versions of TCMalloc where it ignores the thread cache value. I don't remember if Xenial suffers from it though. It might be fixed.
I think I know this bug, and I think it does not. I mean, I think this bug is fixed supposedly. I know there was a long thread on this when we explored it.
Yeah. I think that anything we can do to help TCMalloc is a good idea, or whatever allocator, right? I mean, even if TCMalloc or anything else is supposed to try to do a good job of like creating regions of memory to kind of lay out like-sized objects, anything we can do to help it is probably a good idea.
But I'm afraid that this could turn into having a memory allocator over memory allocator. Still,
Yeah.
we will need to take care, a lot of care about, for instance, migration data between threads. If you want to use the object pool outside of your sister world, I would expect that we will need to handle the case when memory flows between threads.
Well, in addition, though, I mean, one of the things I was thinking of is that during the XM Messenger work, Marcus wrote a little italic-like thing, a little thing that a little micro allocator that just pulled up Alex and then freed them at once. So in other words, you could attach that to a request at the beginning, allocate through it, and then discard it whenever the whole thing cleans up.
I see.
In other words, you could force that to happen in the thread that initiated it.
I'm thinking about the very nasty case for TC. When you allocate, you construct a buffer list. Basically, when you do some kind of serialization of data, and in one thread, and pass this huge buffer list,
which we constantly do, and of course in RGW, right? Of course, yes.
Yeah, and there is a clutch actually. If you are using continuous appender, when it sees a buffer list, even if this buffer list is 8 bytes long, it tries to avoid memory copying for all costs. As a result, you are going to create another small portion of memory, buffer pointer. I mean, maybe.
Well, in the RGW case, I think we most common. Well, go ahead. Sorry, but in the RGW case, we most commonly are receiving a large chunk of memory, right? Where the case we've seen a case, for example, in writes. The writes are coming in pretty big chunks, and we want to append them a new buffer pointer for that.
Definitely, the problem is with appending small buffer list. If your buffer list is tiny, it has 16 bytes inside or something like that, then going with the memory copy saving procedures I am afraid, would make the things much worse, because you will end with very fragmented buffer list filled with extra small metadata allocated separately. I mean buffer pointers. Then, if you are passing such a fragmented buffer list to be freed by another thread, well, it would impose very significant overhead over tcmalloc, I am afraid.
Radek, in that, what you were just describing, is it predictable what we do with data coming into RGW? If you've got some data that's coming in, is it possible up front to say, we know what we're generally doing with this? We're going through this process of creating buffer lists and doing something with it, and eventually, this is kind of the pipeline that we end up with, and here's where we go.
It boils down to having a compile time configurable buffer list.
Mm-hmm.
But I guess we don't have it at the moment.
Well, but even if that whole process is predictable, that this is what ends up happening, this is what we create, this is how the process goes for creating this temporary stuff that then gets passed off to other threads, and we do all these things, but eventually we end up, at specific point where now we're committing data to something, we're writing it out to an OSD or whatever. I mean, can we distill all of that down into here's the memory allocations that we need to make? It's predictable. It makes sense. Or is that oversimplifying it? Either you or Matthew. I mean, do you know?
Well, there's some things. I don't know if they're all there. I mean, it seems like Ross is working in the right direction here. I mean, off kilter above, but in our cohort work, we simplified the one problem for this particular case. The op request queue or equivalent. Though it didn't, it was, but it did. I mean, what we were actually doing the one thing was we consolidated a bunch of things together. So we were allocating one structure essentially for everything that was going to get allocated down the path. Separately, the way we got rid of it was we actually did have one thread pull on the top and one thread on the bottom, and we had a lock-free queue that we were sending the whole blobs back and recycling them. So the original thread would actually recycle the same thing, or if it did overflow, it would free it.
Nice idea, but with restrictions. Yeah, the most important one is that is the lifetime synchronization. Have very strong coupling because of that, but still might be worth doing in some cases. To be honest, I don't know. At the moment, I would love to gather more data, and I'm not able to do that with perf. I'm thinking about putting some just to even let's roll with the case of checking how fragmented our buffers really are.
Yes.
I don't see a solution using standard tools like perf. Maybe we will have to put some instrumentation inside. Of course, guarded perf counters.
Yes. I would love to see perf counters for even just the number of buffer lists, the number of buffer pointers, the number of raw objects, all of these things. Yeah,
but
and then run different workloads and find out how much variation we see.
I think we would need plenty of macros to be able to steer with this behavior, because putting let's as an example, I've took the slapped allocator. It's at the beginning it was tightly tied to mempool infrastructure. I mean to the sharded but still atomical accounting, number of bytes inside, number of containers, etc., etc., and replaced with that the most frequently used, most frequently allocated guy in wait priority queue, and I got huge regression. It was really huge. At the beginning, the costs of weighted priority queue NQ was about 1.7% of cycles of single messenger worker thread cycles. After that, I saw around 5%. Well, mempool can be costly. Atomical counting, maybe with the new infrastructure, would be less. But still, in such critical places, I think we want to make this the possibility to disable it at compile time. Something like we are doing with the Ceph mutex rework.
One thing I've been wondering a little bit is we eventually stop accepting writes if we have too much outstanding incoming data, right?
Yeah, throttler.
Yeah. We do this already, right?
We do.
So does naturally, does any of this, or maybe not naturally, but can any of this fit into the idea of using circular buffers for incoming data and just overwriting what's already there once something a previous request has eventually kind of been committed in order? Like, do you
Well,
have things?
I haven't thought about that. I'm afraid about that. Okay, circular buffer, and you would block after seeing. Okay,
Yep.
my can be reasonable actually, because in Throttler we have a lot of we have critical sections, atomic counting, all the stuff. I was working on I was poking with Throttler, made some in some cases put and get more critical ones. I was able to squeeze the critical section in most cases from one of such methods entirely. In second one, I went with there is still atomic synchronizing the stuff, but I saw around one and when 1.25% improvement or something like that in matters of IOPS.
If we were imagining a scenario where we rewrote all of the Ceph infrastructure, and I know this is ridiculous, but imagine a scenario where you rewrote all the Ceph infrastructure for accepting and dealing with client data. If you were going to do that, could you put a circular buffer in place, say this is how much memory we have, we're not exceeding it, and now design a pipeline that could accept data and walk through, but not accept new ops until you've cleared enough previous space?
Question. Would it be compatible with the idea of a zero copy pipeline in user space? I mean, DPDK taking data. Let's roll with writes. Taking data from client using DPDK and writing using SPDK.
Mm-hmm.
Idea is
Exactly.
to, of course, is to elite copies. But what after putting a circular buffer between them? Is it? I haven't thought about that yet.
That's something I haven't very carefully, but it's something that I kind of keeps kind of coming up in the back of my mind a little bit, is if we were going to redesign all of this from ground up, what is the thing that would allow us to bring in data in order, block when we have too much, avoid copying memory, avoid doing crazy new allocations in random locations in memory. That's kind of what
shouldn't be it delegated to a lower layer. Basically, it boils to QoS, quality of service. Shouldn't be handled by the in-user space TCP stack of DPDK inside DPDK.
I don't know.
Maybe the whole concept of having such a feature on our own is just wrong.
Maybe. I don't know. I don't know what DBDK actually gives you.
I think it gives you mbuffs. And I think
is there any? Sorry, please continue.
I don't know. I guess I don't know, but I think we're heading largely into CSAR-like territory now, except without the new measurement piece. And I think the goal is I think you need to have awareness of what that memory, all the memory is doing. It's allocating it's allocating units that correspond to segments of information coming in. And I'm speaking about DQDK now. I don't know a lot about SPDK at all, but I don't see how we can escape
I
But
agree with you that we are saying that we're in the C-star territory. My fear is that even when we head into C-star territory, we're going to end up doing stupid things like we currently do, and break the whole thing and not make it work right.
Well, okay. I think it was Dieter from Fujitsu Siemens that had the most powerful slides on some of this on some of the same issues early on, at least 2010 or 11. I saw them. That pointed out that code paths are long. Code paths are subject to scheduling latency. Other things are going on too. CSAR eliminates this.
guys, I just googled for DPDK and OS, and there is a documentation actually.
You have a link? You paste it? Yes, you did. Good.
Just pasted.
Well, it has to have it, but this is just about. I think you'll find it's just about the throttling behavior that connects connected through control to TCP. No.
Yes, having that implemented based on the same using the same mechanism like we have for congestion like the congestion control for in TCP could make things much simpler. Basically, export all that complexity to Intel, to the PDK, to guys implementing the TCP stack in user space that basis on the DPDK.
Well, what complexity do you think you're exporting to them? Because
the wall
they're well,
or circular buffers we could have in the future.
Well, I don't know. I mean, the throttler, yes, because the throttler is budgeting this is operating directly on the TCP segment budget indirectly. But other things that we do are not. They're just dimensioned by it. They're dimensioned by the work we're actually performing, not what is flow controlled or not.
Well, that's the question: whether the features offered by the TCP congestion control is powerful enough to express what we need for the users. I don't know.
Matt, what work can we document that?
Which work are you referring to?
The work you just mentioned.
Oh, the Dieter's. I can find it. I saw it was from a slide deck I saw at SNIA.
Okay.
It just talked about profiling as of, I don't know, Firefly or something. It was just talking about the OSD data path.
Okay.
And it's still I think partly applicable to now. I mean, but it isn't. I mean, it isn't a complete picture. But I'm not completely sure how the two pieces tie up. We have to have. I mean, and there absolutely needs to be end-to-end QoS that's application visible, and TCP, but TCP fits into it. It fits into it by giving us TCP to BDK is going to give us buffers when the connection is not flow controlled, and we're going to have to and the client's going to be affected by whether or not we return results on the association back to its clients. I'm not quite sure how it ties into the other memory allocation pattern themes of this conversation.
It would maybe this is all getting very, very high level and crazy, but maybe one more concrete thing, and Radek, I'm picking on you because you've been looking at all this, is just to document everywhere where we allocate memory in one thread and then destroy it
nasty
in another
patterns
thread.
of nasty patterns of memory allocation inside OSD.
Yep,
good idea.
Just to start out with that as a list of evil. Maybe make a master evil list that we can reference.
Okay, I can between messenger and three items from head. First one is, of course, the weighted priority queue that sits between messenger workers and TP-OSD TPs. Second one is create op, also between between messenger and TPs. Another one is the store cache. It's between TP-OSD TP and the bstore mempool thread. That's the three places I can recall from head.
Okay, why don't you handle OSD? Matt, is there someone on your team that could make an evil list for RGW? I know evil very, very generally, but like anything with bad memory allocation patterns, anything that sticks out to you. I'm starting to believe this is a good idea for us in general to have a list of evil things that we do.
We're certainly interested in it, so I mean, we can do something. I mean, I think one of our attempts is, I think we can look at what kind of instrumentation or things we could do in terms of the conversion to the ASIO framework. I mean, right now, I'm not aware of a terribly large number of overtly evil things. We make tons of use of buffer list. We don't make tons of use of small appends. We move large segments through buffer list. We terribly abuse TC-malloc in the sense that we allocate things and free them in other threads.
Okay.
Or use them in other threads and then free them, and etc. I mean, I'm not sure we won't be making that worse in the ASIO world. So we want that part of the problem we may be able to look at as a separate one. But I think we want to look at whether it's a persistent.
Let's say that somebody would like to profile RGW. What is the topmost prior requirements is to have meaningful, reasonable workload. How it can be generated?
Let's say
I would love to some kind of benchmark, maybe.
COSBench, it's called. Yeah, there are standard or get put as there are standard benchmarks.
Matt, do you feel like COSBench is
but I want to
best option?
Well, I want to clarify. I mean, other than a couple of liminal cases where we had high CPU utilization in TC-malloc, I don't believe that allocator issues are CPU or performance bottleneck for RGW. There are problems.
We don't know.
Well, I think we do.
We need to profile. Let's profile.
I definitely remember seeing this is old, but a year or two ago, very, very high CPU usage with large IOs, like 4 megabyte writes coming in, 4 megabyte objects. Just, RGW was consuming a ton of CPU cores handling that kind of load. I don't know what it was entirely. I didn't look too carefully, but it could consume a large amount of CPU.
Well, we're changing. The thing is, we're changing it. We're changing the model pretty completely in our team. We're doing it pretty soon. In other words, it's happening right now. There's work going on this. So I think that I'll bring this up with Adam Emerson if he's not already on this call. Talk about how we might fit this sort of thing into the ASIO.
Call.
Okay, so maybe we could talk about this in terms of instrumentation we might do as part of ASIOification. Some sort of standard profiling paths and go forth from there. I mean, we have reason to believe that there are reasons why we really want to be in the asynchronous model and garbage collect vast number of threads that we have. Having said that, there'll still be potential for misbehavior, and still be potential for abusing buffer list, among other things. Adam, do you have anything?
Just try to.
Go ahead, Adam.
Yeah, I'm perfectly happy with that idea. What were we planning on trying to? So as I understood it, the idea was that we wanted to try to profile when a new buffer raw was allocated, or when we took a new reference on it, or where we wanted to profile something else.
No, I would just love to see the distribution, even of cycles, CPU cycles burned across RGW. running some reasonable workload. That is, well, some workload, some average workload, like the client, like the customers are running. Just to take a
try to
look
do
on the
something like
distribution,
that.
which symbol, which function is responsible for burning CPU.
Radek,
That's the
it's not too hard to use Mark Seeger's get put benchmark with CBT. You have to use a modified version that I wrote. Well, not wrote. I modified version that I've got some PRs committed to, but yeah, it's good enough for some basic, workloads.
so it's. You have maybe a link or something like that, just as a foundation of.
Well, yeah, we have all that whole workload tools available to you. But I wouldn't suggest. I'm not sure. No, I don't think that RW's workload is a good substitute for OSDs or more or
No, it's not.
More suitable target. For this. I don't think you're going to find where we may find howlers and things we can fix, but we're not going to. I don't think we're going to be adding the value to the heart of the argument, except maybe the CC malloc argument, at least right now.
So it's you are saying that RGW is bound not by its own CPU utilization, but the throughput offered by OSDs.
That is what we've observed to this point. We spend now. What is also true is that in read and write operations, we send massive amounts of data through the process and to and from Rados, and under a few uncommon workload conditions, at least in a couple of platforms, as we've said, we've seen a reasonable CPU utilization in CC malloc.
Matt, the case where I've seen where RGW becomes a bottleneck is if you're dealing with very, very fast OSDs, like on NVMe devices, and you're pushing a huge amount of like large object data. So like 40 gig E plus kind of scenarios where you've got a single RGW instance on a very fast node talking to very fast OSDs.
Yeah, and I can go into other hand waving on this, but I think that you're right. This is critical, but I think it should be framed in terms of testing after we've inked in two things. One, the new ASIO dispatcher, and two, the connected QoS framework we're trying to put in place, because we want to we're trying to build a DM clock based QoS that's at the RGW level, that's linked back through dynamic queues that Eric has added into DM clock, and at the Rados level, to have connected QoS, for GC and for regular client I/O. At that point, we've both changed the problem, but we've also introduced new places where CPU bound processes, especially in the DM clock algorithms, for example, could appear.
The ASIO stuff is going to dramatically change your TC malloc story too, isn't it?
Oh, exactly. It's going to put it in a blender. I'm not sure it's going to fix it, but it's going to make it all different.
Yeah. I think I agree with you. If this is even semi-imminent, I'm not sure it's worth it.
It is imminent. So, but I agree with it. Once we get those things blocked in, we should begin cycling this and continuously looking for how we can get close. Why we're not getting optimality at that point. What should be done.
Sure. Okay. How imminent? Like what kind of time frame do you think on that? Very roughly.
Adam.
I'm currently in the middle of putting together our API, so we ended up leaking implementation details all over, and then once we work out the bugs, we should be able to start hammering it into RGW.
Okay.
Oh, a couple months.
Would
PRs will start landing.
I was gonna say like a year. Would that be?
No, we're talking about November.
Okay. That's good to know, because that means that I need to.
The work's been going on for a year, and then the QoS stuff as well. I mean, it's all kind of. aiming it now.
Okay, cool. All right, I'm not going to worry about it until November, I think, at least. But we have ways we should be able to start collecting some profiling data on RGW with this. So, if you guys don't, I can, or somebody else can probably get something.
Well, no. Well, it'd be useful to collaborate with Mark Kogan of our team, and Raroslav, you're welcome to do as well. I mean, he's been running Cosmage-based workloads where he's focusing on various things, but he's shifting in the direction of looking at QS at both on the OSD tier as well as RGW. We'd like to begin turning it on by default and learning how to get through the last open issues there, as well as push up into the RGW layer and get that stuff completed.
Yeah. And I know this is a sensitive topic, but anything you guys can do to avoid a service registry and focus on black box would be fantastic. Black box testing of specific components.
When you speak of service registry, what are you referring to, the refactoring PR, or what are you referring to here?
Oh, I don't even know what I'm talking about. Just anything that can make it so that we can load specific C++ classes and do black box testing on them and avoid.
So you are referring to the thing I'm referring. So you are referring to the thing that I'm referring to, Mark. Yes, we're doing our best, sir. This is a debate that is ongoing. So
yes, I will say I have no idea what I'm talking about. I don't know anything. I'm not involved.
You've raised another point that is for the hopper.
Yes. So good work. Keep it up. Black box testing is fantastic and good. Looking forward to hearing about it. That's all. All right, we're like 10 minutes over time, guys. We should probably wrap it up.
All right, thanks, guys.
Yeah,
thanks, Raroslav.
Have a good week.
Very interesting work, Raroslav.
Yeah. See you later, guys.
Thanks, guys. See you later. Bye.